Yeah. Okay. I think I'm going to try a naive solution to see how fast it runs, and I know that we talked about, and then try to maybe optimize a little bit. Because I think one thing that I like to do when I'm a little stuck is just visualizing the code a little bit better, and then kind of see if I could figure a way to see the patterns. Um, yeah, so that's basically what I'm going to do now. And yeah, and the first thing I'm going to do is I'm just going to put all the word lists into a set. So yeah. Mm, um, yeah, okay. And also add n word so that we get there. We'll make sure that I'm not sure that n word is. Oh, actually, n word has to be in the word list. Okay, so that's not okay. So then now, as we said, it becomes a breadth first search. So let's just do that naively. So we have a queue is equal to collections.deck. A deck is basically a double-ended queue. So yeah, definitely look up on it. But I'm going to use it just as a queue. So yeah, the API is the same, and that's how you do it in Python. But okay, so then now what? Well, let's start by inserting the by adding to the queue, the begin word, right? Um, and let's also have yeah, like a list of words that we've already seen. This could also maybe, if we really want to, we could also map this to an index or something so that it's a little bit more efficient. But these are optimizations I'll do in a little bit. Yeah, and then now we do while length of queue is greater than 0. Queue dot pop left. So now we have to, and this is a little bit templatey, but it is what I generally do. You know, I pop push thing on the queue, and then for each item I pop it off, right? And then now, okay, now what do we do, right? Okay, and then now we just relax edges as we do in a breadth-first search, and we, so, and what are the edges, right? Well, there are at most m edges for each one by looking into hmm, maybe this doesn't make sense actually, but so there are two ways to kind of do this. One is just having like a placeholder character for each one, but it takes m of them, so maybe a little bit too slow. And the other is hmm, the other is thinking about different ways of the other one's just thinking about different ways of brute forcing it, but that probably is too slow. So okay, let's actually as we said earlier, we'll do a fuzzy hash thing, except for we'll let the code do it for us, right? So then now let's actually pre-process. So words is equal to set for you want to do it this way? Yeah, okay, fine. Let's just yeah, default dict of a list that this basically just creates a dictionary that defaults to list for word and word list. We want for index in range sub n or m in this case, where we all have the same length, right? Okay. M is equal to length of the begin word. And then let's have a helper function that gets us all the different all the different things. So I think this actually may end up being slower because I think Leetcode is really bad about these helper functions in the past. So okay, so let's actually skip that now. definitely you're trying to write clean code, I would help. Okay, fine. Let's just write a clean, and if we get a time limited, we get a time limited. But okay, let's just say get word list for word, and then for index in range sub m, we want to yield word up to index plus some placeholder. So let's just say star, and then from that on, I think this should replace this, right? We'll double check it. But yeah, but now we can do for each hash word, maybe. I don't know. Naming is always tough for me anyway. A word, we do words sub hash word is equal to word, or append word, right? Okay, let's remove these for a second, and let's print out the then we can kind of visualize it a little bit just to make sure we're on the right track. Okay, so this is basically what we want, right? We want it to yeah, and I guess if you want to do regex expression, this is actually, we should probably replace it with period, but that's okay. But this looks basically what we want, so I'm happy about that. But yeah, then now we can do this thing, and then now we can do for I don't know, again, hash word in get word list of the current word. Now what do we do, right? Well, we want to look up this word list. So for possible word in word sub hash word, then in here we check if p word is if it's not in scene, then that means that we want to go to it. So we add the p word, and then we just append it to the queue. So the distance will be d plus 1 plus the new p word. But yeah, and also if p word is equal to n word, then we return d plus 1. Otherwise we return 0 at the very end. That's basically the idea. It should be okay, minus some silly things, and maybe off by 1 because I don't know how they do it. So how they want to count their how they want to count the edges. For some reason, yeah, the chain has 5 words, but the length, but it's 4 edges, and I count the edges, so we can just fix that by adding, starting at 1 for the number of words. But again, I don't, some of this is just being a lot of practice, so I'm confident-ish, minus some typos, that this is the idea, but only if it's fast enough. I don't know if this is fast enough. Okay, well, so this is fast enough, but it is a little awkward because the constraints can definitely make it so that it is not fast enough if they really want to. So this is an example of I wouldn't say a weak test case, but a misleading test case constraint. So yeah, because what is the complexity of this, right? As I said, okay, so get word list is going to be O of M, right? Because for each word, this is O of M complexity, because we have a for loop that's O of that's takes M, right? So that means that for here, well, we have N words. This is the pre-processing N words, and each of them we get M other words, and then each of those we do this thing, right? And depending on how you want to define it, this actually is also O of M. And the reason why is because putting a hash table with the key being a size a length the key being an element of size M does take O of M to hash to a table. So well, it's also the input size to that thing, right? So you cannot do faster than O of M. So this is going to end up being O of N times M, just for the pre-processing, right? And even then, even we look at the constraints at the worst, that means that it is 5,000 times 100 times 100 is already 50 million, right? So that's already kind of slow. This would have prevented me from maybe solving it during the contest unless I really gave up on it and like have no other ideas, which I might not, and just try this way. Yeah. Or you're so experienced that you know that there doesn't exist a better solution, which is kind of hard even for me to say, because there's a lot of literature out there, a lot of techniques out there, right? But yeah, and that's just the pre-processing. And here, this loop, well, for each item we insert once, so that means that this is going to be O of n iterations. And here again, this is O of m, and this is also another O of m, and yeah, I mean this is O of m because they're, oh no, sorry. Well, this is a little bit tricky to analyze as well, but this part is going to be O of m inside, because, well, we do a lookup to see if it fits in scene. We do this comparison, which takes O of m to compare two strings, and adding scene again. So this is O of m, and this is even like, I don't. This is also O of m, and the reason why is because for each character it appears on this times, but you can also say that, yeah, so yeah, because for each word that you relax, it appears on m other lists, right? So that's basically complexity, which means that total complexity for this thing is about O of m or n times m to the cube, which is really slow, right? Which is what I mean, in Python, some of the string functions are optimized, but it's still going to be very slow. So it just depends on the output. So yeah, so that's why I didn't think this was going to be working, and I was just hoping that we'll see, because this should be a basic question, a common question, but I don't know why they made the constraints a little bit kind of scary to analyze in the worst possible case. It might also be that the worst possible case, because of the inherent nature of things, just be too fast. Maybe also I may be wrong in the analysis, so definitely let me know. Because basically, if you look at it as as we talked about in a graph edge case, there's going to be at most 5,000 nodes. The number of edges for each node will be at most 100. So I don't know, right? But anyway, in terms of, so that's the time complexity. For space complexity, let's see, right? Here, so each word already appears O of n times, or there's O of n words, and for each of them there'll be m of them, and we store it in m places. So it's going to be n times m squared again for space at least. And yeah, and the queue as well, but that part is not as much, and the set. So it's gonna be a lot of characters, and maybe there's some compression and stuff like that, but that makes it even slower. But besides that, so yeah, it's gonna be n times m squared space, which is kind of crazy. Wait, is it n? Let's see. Yeah, each word, each of the n words have m edges, so it appears in m times, and each word has the length of m. So we're storing n times m squared in space, which is also very scary given these constraints. But apparently, the test cases don't really test this. So yeah, cool. That's all I really have for this problem. I think this is a little bit weird and tricky because the constraints don't really represent the worst cases. And definitely we can come up with worst cases. Just, we can generate them programmatically to kind of prove this. But I'm okay for now. So yeah, so that's why it's a little bit tricky to kind of think about it, because if you don't think about it complex enough, you may just do it this way and be like, okay, should be fast enough. But when you actually do the complexity analysis, it's actually a little bit slow. So I don't know. It's weird in that way. But yeah, let me know what you think, and I will see you tomorrow. Bye bye.